slowly get into it. Welcome to this late afternoon session that I chose to title 15 Years of Spring, just because of the opportunity. The Spring Framework actually is 15 years old, or well, technically it will be 15 years old in about 2 months' time. So yeah, it started in the very 2002, very year 2002, and I actually got involved in January 2003 or late December 2002, so we're almost there anyway. So, this is actually a good point in its own right. My own role in all of this, I have been serving as the Spring Framework project lead ever since that time. So I am actually in the same role, in the same primary role for about 15 years now, so for that entire period. I literally managed and released and signed off the Spring Framework 0.9 release back then, and I still manage every single Spring Framework release, even every maintenance release up until this point. So you get it very much of a personal perspective here to some degree. The idea behind this session is that I'll tell a few stories along those lines. We will actually primarily focus on the more recent history, of course. This is a little bit of a trip down memory lane, but just a little bit, and just initially, I will spend most of the time on all the things that matter today. So basically the evolution in the past few years, in the most recent generations of the framework, right? Quick poll. Who's an active user of Spring here? All right. Inverse question. Who hasn't seen or touched Spring at all? No insights whatsoever? That's all right too, although a few things here kind of might not immediately make sense to you. I hope I can make some sense of them. This is a Java ecosystem story after all, right? Spring is not an island. Spring never was an island, never intended to be an island, so Spring very much co-evolved with the entire Java ecosystem, in particular with the JDK itself, with the Java EE specifications, with many other open source libraries in that space. Anyone not familiar with the Java ecosystem at all? I guess this is kind of self-selective here, since there's Java in the title. I am aware that this conference is not primarily a Java conference, primarily I get listening to other talks. I had quite a bit of .NET exposure, and that's all cool, of course. But my personal involvement always was in Java. I actually started writing my diploma thesis in Java back in 1999, and never really left the space ever since. So I kind of do look beyond the horizon every now and then. But I'm deeply entrenched, personally entrenched in the Java ecosystem for almost 20 years in the meantime, ever since my first Java project assignment in '97. All right, let's get into it. How did the times look like back in 2002? Well, it all started with this book. This is slightly unusual these days, but wasn't as unusual back then, to actually have like framework downloads along with the book. I mean, it literally was just a download in the materials that you could get on the publisher's website. Initially, that was Rocks as a publisher, so you could go to their website, download the zip, and there's a little bit of code inside that was sketched within the book. This was a 600 plus or 700 pages book, so plenty of exposure also to some of this code. It was very rough. Basically, a couple of framework ideas. Actually, some ideas that are still around today, but most of the present-day ideas are actually more recent than this book. It was packaged in COM Interface 21. That was just a domain that Rod Johnson, the author of this book, happened to have. So no particular choice of name. The framework itself didn't actually have a name. So in this book, this was kind of the unnamed framework, right? That just the ideas in that book are distilled into some early code, right? I actually read that book in Christmas break 2002. So I got it in sometime December, but didn't get to read it before the time between Christmas and New Year 2002. And I liked a lot what I in many ways liked a lot what I read there, and I in particular got interested in these framework ideas. Myself at the time, I was already an active user of quite a few open source components, had a background in Genie and Java Spaces in the early servlet development kit, the initiation, the initial versions of Tomcat, the very early versions of Tomcat at that time, and well, struts, Apache struts. Anybody remembering struts? Yeah, struts was a thing back then, and I was not happy with struts in particular and with other options at the time. So I reached out to Rod, literally dropping in basically a note on this author feedback forum on the website, and suggested, couldn't we turn this into an open source project, right? As a download for a book at the time, it was already, you couldn't do anything with it other than get inspired by it, right? What about turning this into an open source project? Along the lines of the then quite recent struts and the then fresh Hibernate, couldn't we create a framework open source project for it? And Rod was saying, sure, but I just spent 9 months writing this book almost exclusively, so I need to get back into consulting and earn myself some money. But if you agree to share the load, right, like 50-50, actually participate in that framework's development, then I'm certainly up for creating it as an open source project, as a formal open source project. And that's exactly what we did. We set it up on SourceForge, was a thing back then, right? The GitHub of the times. So on SourceForge, in just a few weeks later, late January, and went live with it, got the first opportunity to be featured also on the serverside.com back then in early 2003. That's how it all started, and that's how kind of I started in that role, and I basically never left it since. I was in a software architect role back then, was already venturing on self-employed, turned completely self-employed afterwards, and in the history that follows, we set up a company between the two of us about 1.5 years later from that period when I read that book. So there was a bit of an intermediate improvised form, but we always took the framework forward, right? The business model might have been a bit rough initially, and we just tried to kind of make a living with it, but we already started the continuity of delivery that still is very much a characteristic of Spring today. The initial 0.9 release dates back to mid-2003. If I remember correctly, I published it right before going to the airport for the server-side symposium. So those times. This was 0.9, very rough, still in the COM Interface 21 package. We already chose a name. This was just a few people involved in that feedback forum for the book. We knew we had to find a name, but we didn't actually repackage it. Only for the 1.0 line, it was org.spring framework when we got the domain and started using the package name. So Spring as a name, of course, was turns out to have been a very memorable name over the years. But back then it was like, we could do anything and everything, right, as a name. Try to name a project, right? Try to name an open source project, as they say. What's hardest in software development, right? Naming is one of those things. And in particular here, you choose a name for the SourceForge project, and on SourceForge you can't change that name ever, right? You can just move to a different repository of a different name. So we really tried to spend some time thinking about the name, and I'm really happy with it ever since, really. Right, and of course, this was only the beginning, right? In March 2004, 1.0 GA, we had to go GA at some point. We knew, and we still know, that deliveries basically, and what it's all about, right? Just coding along, but never really releasing and never being willing to support it, this doesn't cut it. So we started going live in March 2004, and we're already very actively reacting to feedback. We were actually surprised how many downloads we got. Like the release candidates already had like in the early 10,000s, low 10,000s of downloads, which was way more than we anticipated. But once we went live with 1.0 GA, it was, of course, the beginning of quite a mainstream period. So just summarizing, the early times didn't really allow for the modern day variants of Spring, right? This was JDK 1.3, 1.4. This was XML-based bin definitions with a couple of other formats that were supported, but everybody used XML bin definitions. There was JDK 5 already in early access, and shortly after its release in late 2004, we started embracing some things like this transactional annotation in Spring Framework 1.2. We tried to be very receptive to any other variants, right? We even had support for the JavaDoc embedded metadata formats in Commons attributes, it was called at the time. But this was all superseded very quickly when JDK 5 went live. Unfortunately, a problem of today was already a problem back then. Just because a new JDK is available doesn't mean that people are actually using it. JDK 5 took quite a while, several years, before it actually became common. Not least of it all because Eclipse, as an IDE, wasn't really supporting it very early and so forth, right? And on the Spring MVC end of the spectrum, this was actually a quite traditional class hierarchy, inheritance hierarchy with the control and the view abstraction, but already based on dispatcher servlet, already based on the same view abstraction that is still in place today, just no annotation-based dispatching, more of a traditional controller implementation arrangement. The open source projects of the time, just to give you also a visual reference back to them, Eclipse was set up in 2002, if I remember correctly, so pretty much establishing itself around that time in the 2002-2003 period. Might have been 2003 actually that they did the first release. I'd have to check. I was an IntelliJ IDEA user. Even back then, before Eclipse even was a name, I was already on IntelliJ IDEA and I never really left it. So I'm more of an observer in the Eclipse space. Tomcat was a fresh project, a donation from Sun. A little bit rough, right? Just a Linux build, and it wasn't quite the Tomcat initially that we know today, but it turned into it. It got popular in the Tomcat 4 and later the Tomcat 5 area. So a very important partnering project. Spring on Tomcat was a very popular combination. Actually, struts on Spring on Tomcat, or struts for the web layer, Spring for the service layer, Hibernate for the persistence layer running on Tomcat, or Chatty, was a thing back then. So it had even had a name, right? The Struts Spring Hibernate stack. Because Struts was also popular, right? In the JDK 1.4 glory days. Unfortunately, Struts never really made its way onto a JDK 5 plus generation, right? It kind of got outdated with the dominance of JDK 5, with JDK 5 establishing itself in the market. Right, we actually kept writing books. There were 3 in that series. This is actually the last one. In that period, it's barely recognizable, I guess, but this is me. Books actually were a huge distraction. We stopped writing books afterwards. We really motivated people in the community to write books instead, because there's only so much time in everyone's day. And we knew that we had to make some money. We were consultants and trainers at the time, half of our time, and the other half was open source development, right? If you then also try to write a book, then your days kind of, you run out of time every single day, right? So this was pretty much the last book that all of those 5 were involved in. A much more important undertaking was the Spring Framework 2.0 launch, the first major revision. It wasn't a re-architecture at all. It was a continuous evolution of the ideas in Spring 1, but it brought lots of things. The more feature declaration-oriented configuration. Initially XML namespaces, but it still shines through today, right? At enabled transaction management and so forth. It's the same idea. Declaring a feature, opting into a runtime feature through a simple configuration mechanism. Actually, those are of course still around, the XML namespaces, and they are quite popular in corners where you wouldn't expect them, for example, in the Groovy-based configuration in Grails. In Spring Framework 2.5 actually came just shortly thereafter. We started a strong focus on annotation-based programming. The early days of class path scanning, at auto-white annotation dates back to that period, the qualifier model, the annotated controller idea with request mapping, handler methods, and the flexible signature. This all dates back to 2.5. We kind of meant to do this a little earlier, but there was just too much on our plate. So 2.0 went out with all the XML namespace and AspectJ support of the times, with the JPA support of the times. JPA was also a thing back then, the Java Persistence API. in its 1.0 incarnation. And in 2.5, we caught up with JDK 6 and with the annotation story, kind of the second half of what we actually meant to accomplish in this particular generation of the framework. And of course, we continued from there. The aforementioned Grails started building on Spring Framework. So in the Groovy community, a large dedicated community in the Java ecosystem to this day, the Grails web framework is actually Spring-based. It's Spring MVC-based. And this turned into a quite important factor over the years. Lots of input from their side. It does have a very different feel to it after all. So Groovy and Grails not only were community projects, we actually onboarded them into what became Spring Source. In the meantime, we were a company with, well, at that time, approaching 100 people, I guess, and maybe in the ballpark of 70 or 80 at that very point. We actually, we had a round of venture capital. We started acquiring, including the company that was behind Groovy and Grails at that time. So this actually became a very close part of the Spring ecosystem. And I have to mention there, that at the time we started having a marketing department, right? We never had marketing people. We always just had ourselves, connections to the server-side.com, us appearing at conferences. But then we had a marketing department, you know? You get venture capital. What does a VC want from you? Kind of build a sales force, like a sales team, and invest into marketing campaigns. So we had a marketing department and it did marketing campaigns. And this was one of those campaigns. It's actually quite indicative. Weapons for the war on Java complexity, right? I mean, I guess it shows that it's been done in the US, right? Would you in Europe ever, well, yeah. When I first saw this, I almost fell off the chair back then. It's about 10 years old. You know, the fighter planes and the battle boats and the tanks. It says Spring over here on TC server, which is the supported Tomcat distribution that Spring Source and now Pivotal has, and DM server, the OSGI-based companion server. Complexitania, right? I mean, in the US, of course, you declare war on everything. War on drugs, war on I don't know what, right? War on food shortage. I have no idea, right? They are very liberal with their use of the term war on an everyday basis. But even the imagery is just, yeah. So we got rid of those campaigns. It was much lighter afterwards. This only happened once. But there is actually something hiding in here. The war on Java complexity, right? Why would you declare war on it? Well, there were many offerings at the time. JBoss really established itself. WebSphere and WebLogic were huge at the time. Plenty of open source frameworks. The CDI specification was in the works for Java EE6, so kind of also covering the dependency injection part of Spring. There was really a degree of complexity that had to be managed. And to this day, that's true, right? The modern day Spring Boot essentially manages the complexity of dependency management in the Java ecosystem to quite some degree. So there is a grain of truth in this, even with this imagery. The portfolio in the following few years turned into quite an arrangement, right? The Spring Framework at the center, but we actually turned into a portfolio of projects. And the way we are running this is that every one of those is an independent open source project, these days on GitHub, and has a dedicated team, a dedicated project lead. So myself, ever since its inception, I have been the project lead of the Spring Framework core project, which is pretty broad, includes everything from the core container, AOP support, JDBC, JMS, the basic JPA support, and all the web support, right? Almost all the web support, right? The modern day web support, like WebMVC and these days also the WebSocket support and the WebFlux support. So a couple of people on each of those projects, right? This was already a very successful strategy back then. Let people innovate in their own part of the ecosystem, right? Don't enforce too central a management. So there were independent roadmaps here, independent decisions made by the project leads, to the degree where some teams would choose to use different issue trackers or different IDEs of preference. So we actually turned into the quite multifaceted portfolio that we are still in today. So that was about 2009, when actually two important things happened. First, Spring Source got acquired by VMware, became a division of VMware at that very point. And our almost 2-year work on Spring Framework 3.0 wrapped up towards December 2009. Finally, being JDK 5 baseline, we were able to do a lot of goodness, many refinements across the code base, var args, and well, generics for a start, right? Being available for our API design purposes, not just for optional features, but at the very heart of the code base. So it was a much more streamlined arrangement at that point when we got rid of earlier JDK support. In 3.0, there was a ton of feature ideas culminating. We had several R&D projects before, which we kind of merged into the Spring Framework mainline at that point. The idea of configuration classes was already around for about 2 years by then, but just as an add-on, as an experimental add-on, not as a core part of the story. Same goes for the Spring expression language, which is primarily meant for configuration formats, but turned actually into a quite popular piece. It's used for routing expressions in Spring integration and for many other purposes in the Spring ecosystem today. It's always the same expression language. So many of the concepts that we see in modern day Spring, like configuration classes with the add bean method and the add enable model, date back to that period. Most of it in 3.0, the add enabling annotations came in 3.1. So the Spring MVC side of the story, it was almost a reinvention. Actually not a re-architecture, because most of the foundation was exactly the same as before, but there was a new usage model on top. The 2.5 started annotation-based model got much more sophisticated here. More REST-oriented, had path variable support, very flexible signatures with very useful additions like request header extraction, cookie extraction in a very convenient way, right? It's all about convenience after all. I mean, you can code anything against the servlet API, but it was about providing a more guidance and also more convenience in the web layer in web endpoint design. So it was a sort of reinvention from a usage perspective, but we never actually had to turn the fundamentals around all too much. So the state of the art at that time, just to give you a kind of snapshot that is still relevant today, what we're seeing here is basically Spring 3.0 level, right? A refined, sophisticated annotation-based component model that we started, of course, fine-tuning over the years with additions here or there, but the essentials are really easy to distill, right? Classes with state, with managed instance state, can have a scope. By default, they are shared singleton types. They come with a stereotype annotation on top with indications, for example, lazy init indications also here at the type level. With injection points, we call them injection points, right? This can be a constructor arrangement, it can be at auto-wide on fields, at auto-wide on setter methods or on other configuration methods. And a very important part of the picture, also showing here today, although it's actually quite a few years old here already. We started introducing a transaction in 1.2 after all. But it's much more convenient here. At enable transaction management, declare a transaction manager implementation, off you go. We are trying to intercept those methods then, creating a proxy for them. Whenever the call comes in, it goes to the framework, then we start calling that method, and at the very end it goes back to the framework and we trigger a commit or rollback for you. All of those ideas were already in the same convenient form that we are consuming them in today. So to quite some degree, the 3.x line was already a culmination point of those efforts. So we thought, at least, right? Configuration classes, this is 3.1 style, right? Same idea. Configuration, the aforementioned mentioned at enable transaction management, and add bean methods is a convenient way of declaring beans to the container. The container introspecting those signatures, deriving a name from here, getting a type hint through the return type, and having metadata for each bean definition derived from this factory method. Every time a new instance is needed, the container dispatches back to this factory method, right? So a very central idea, in particular in Spring Boot. This is a very essential piece of Spring Boot, started in this period. We've just to be clear, we fine-tuned this basically every year, right? Every 1.5 years. We had the feature releases 3.0, 3.1, 3.2 on a quite regular pace. 3.1 to 3.2 was a bit of a long break, almost 2 years. It was mostly shorter than that, more in the 1 year ballpark. So we always got feedback. There was always a cycle involved, which is very essential to the evolution of any such programming model. If you just kind of go to a drawing board every couple of years and try to come up with new ideas, this would look very differently then. We always had usage feedback. People trying to put this into a real life context, and to quite some degree large contexts. Spring always had a strong position in the financial industry, in public administration, in insurance, in many domains where there was large-scale, long-term usage, long-term investments from a corporate perspective. So there was really an expectation that we carefully evolve this model over the years. So we were facing the challenge of, well, doing yet another major revision, right, which was turned into Spring Framework 4. And Spring Framework 4 is, of course, in its 4.3 incarnation, very popular today. Got released in December 2013 eventually. It took almost 4 years, but keep in mind, there were very rich feature releases in between, 3.1 and 3.2. In most, I mean, this is versioning, right, version numbering. Many other open source projects, I guess it's fair to say that many other open source projects would have called 3.1 4.0, would have called 2.5 3.0 back then, would have been more liberal in bumping up the major version number. And we would have been at 6.0, I guess, if we followed such rules. We were much more conservative. We only raised the major version number if there was a major change in the system requirements, the JDK baseline being raised, the Java E-like servlet and JPA baseline being raised, a chance to revisit the entire code base, basically based on new assumptions, right? New fundamental requirements. So 4.0 was a perfect opportunity to do just that. We raised the baseline again to JDK 6. We removed lots of deprecations that we accumulated over the years. We tightened up our own ways of dealing with the code base. Many measures in terms of enforcement of certain rules in the code base actually date back to this period. It was kind of a huge cleanup in many ways. We started, of course, doing JDK 8 support at the time. Now, if you check the release dates, right, JDK 8 actually went live in March 2014, 3 months later. But it was meant to go live a little bit earlier, and we didn't want to deviate from our roadmap too far. So we released our 4.0 GA in December 2013 with very rich JDK 8 support, simply compiling against the JDK 8 release candidate of the time. Don't tell anyone, right? We shipped the production version of the framework against the non-production version of the JDK. But of course it was JDK 6 baseline, right? So we had production support from day one on JDK 6 and 7. The JDK 8 support was sort of a preview for another 3 months. But this actually was a very important step that we took. We had a look at JDK 8 and found it as a great inspiration in many ways. And JDK 8, of course, is a very essential milestone in Java's recent history, or Java's history overall. So we found it important enough not to defer it any further. This was, of course, an early investment into a Java 8 story. We knew that nobody uses Java 8 in December 2013. And it took a while, even in 2014, for Java 8 to properly establish itself. But Java 8 actually established itself much more quickly than any other new JDK generation before. There was strong IDE support, even in Eclipse, quite soon. There was lots of the tooling actually updated itself very quickly. And people just embraced it, right? It was by far the most immediate uptake of a new JDK generation that I have personally ever witnessed. It's going to be very different with JDK 9. I'll add a few words on that at the very end. So we of course took it to other levels as well. There was a new Spring messaging module here, the messaging abstraction, generalized from Spring integration, being used for Stomp on WebSockets, being used for GMS, being used by Spring integration for the DOE at the time. Well, WebSocket support actually was a totally new topic where I personally thought like, yeah, WebSockets, that's like a little corner of the market. We're doing this because we can, but it's going to be a niche. Turns out that this was one of the most popular initial features in Spring Framework 4. The WebSocket support, the one where we had lots of production feedback shortly after going live with it. I am often totally wrong in my predictions, I guess. But this is exactly what the evolution of a framework is about. You have to make some assumptions. You have to make some choices of what you find really important, like JDK 8. Well, WebSockets we thought is also nice to have, but it turned out as very important, right? You might not always be right, but you have to make some bets and set some direction and have some vision for it. So in the programming model space, there were lots of refinements. A re-implementation of the injection matching algorithm, where we find out for an injection point which bean you might possibly want to have injected here. Taking into account deep generic structures with type variable resolution and much more sophisticated than it was before, in order to get rid of the need for qualifiers. So this is essentially about type safety, about reducing the need for extra metadata in your source code, where the type declarations themselves are expressive enough for the framework to react to them at runtime. And in 2004, of course, in 2014, sorry, we of course launched Spring Boot 2.0, Spring Boot 1.0. And shortly thereafter 1.1, 1.2, and so forth. So this started being the foundation for Spring Boot. And Spring Boot, of course, brought lots of things to the table. The whole auto-configuration model, the health endpoint story, the dependency management, where you basically get a starting point, a bill of materials with suggested versions that you could be using in combination, and a Spring Boot upgrade would softly upgrade those dependencies like the Hibernate version, the Jackson version, and so forth for you along with the boot upgrade. Spring Boot turned out to be a great entry point into the wider Spring ecosystem, not just Spring Framework itself, but the wider ecosystem around it, including Spring integration and so forth. So this was, of course, Spring Framework 4 based, and many facilities, lots of the refinements in Spring Framework 4 were actually designed for that purpose. The whole conditional bean definition model, and many other facilities were and still are designed for use in Spring Boot. So the foundation for the configuration power that you get with Spring Boot actually comes out of Spring Framework 4 core here. The other topic that I mentioned on a slide before, composable annotations, just to give you an idea what that means. This is more of a design mechanism, not so essential for Boot, although Boot does make some use of this. It's building your own annotations, right? What we call composable annotations means declaring your own annotations, adding meta annotations on top, so annotating your annotations, declaring annotation types yourself and meta-annotating them with framework annotation types in order to combine certain characteristics into a single suite shortcut, right? Like this at my service here, expressing the combination of characteristics above in one single reusable annotation that you may use across your code base. This was part of an initiative, actually of the same initiative that I hinted at before, where we are trying to avoid extra metadata, reducing the amount of metadata in your source code to the essentials, not repeating yourself too often, and making your code more readable, giving your annotations or generally your source code elements a proper name and not being irritated by too many other artifacts hanging around there. In 4.3, this is actually a quite late edition, we also fine-tuned our web annotations quite a bit. So if you're looking at demos these days where you see some Spring Web usage, you might see those get mapping, post mapping annotations and co. There was actually a more general annotation called at request mapping before, still around of course. Those are just composed annotations. Literally, get mapping is meta-annotated with at request mapping and hard codes the HTTP method get. The idea is that we provide a little bit of guidance by shipping some new annotation variants out of the box. This was also an initiative, a carefully planned initiative where we selectively added some annotations out of the box. You could create those yourself and kind of combine the characteristics yourself, but we intended to make them more mainstream, intended to provide guidance through pre-composed mapping annotations and also through pre-composed scoping annotations that went along in the same release. In Spring Framework 4.3, quite recent, 2016 era. All right, so this leads us to Spring Framework 5.0, that's right where we are right now, right? Spring Framework 5.0 is actually sort of a companion of 4.3. That's the other part of planning, right? You can only plan so far. We actually only planned Spring Framework 4.0, 4.1, 4.2. We meant to leave it at that and go 5.0 afterwards. Then it turned out that our Spring Framework 5 plan was actually much more elaborate and much more challenging than we initially assumed. We meant to have JDK 9 support. Every time we had a target date for JDK 9, Oracle moved it out, right? So we kind of knew that we had to chase that a little. We couldn't rely on the target date there. Java EE8, there was total inactivity in 2016. We didn't know whether it would happen at all, but we were interested and invested in Servlet 4.0 in particular. We really wanted to make that happen. At Pivotal, we have a Tomcat team. We have 3 full-time Tomcat committers, so Tomcat 9 is a Servlet 4.0 implementation, and we really meant Spring Framework 5 and Tomcat 9 to be a great combination. Have out-of-the-box Servlet 4 support for everything it has to offer in Spring Framework 5. So we wanted to wait for it, really, in one way or the other. We had the functional API design topic. As an important part of that story, the Kotlin language as an inspiration for functional API design. And we, of course, had reactive architectures, reactive web architectures in particular. There was so much inspiration to get out of those themes that we knew that would take a little bit of time before we could go live with it. So what did we do? As the responsible maintainers that we aim to be, we decided to ship a 4.3. And 4.3 brought many refinements into the 4.x line. More quickly, basically more than a year in advance of 5.0, right? So Spring Framework 4.3 went live in June 2016, basically 15 months before 5.0. So we brought it to you earlier. We also brought it to a JDK 6 baseline. So all of the refinements in 4.3, like, for example, these mapping annotations or the composable annotation refinements, those things were actually available on JDK 6, 7, and 8. And they were an immediate upgrade path for existing Spring Framework 4 usage, right? So in many, many ways, we brought lots of goodness into 4.3. 4.3 is one of the richest feature releases we ever had. And we had again a kind of design vision, right? We wanted to wrap up the annotation-based model in the 4.x line. So many of the annotation-based refinements for the annotation-based component model went into 4.3. We chose to use different inspirations, right? Different lines of action in 5.0. So we separated the efforts a little. So in 5.0, it's not much about annotation refinements. The annotation-based model is around as it always was, but it's only fine-tuned in certain corners. Almost all of it went into 4.3. All right, so in the end, we did wait until September 2017 to go live, just 2 months ago. We did pick up JDK 9, which was released a week before. We picked up the Java EE8 specification, Servlet 4.0, Bean Validation 2.0, in particular JPA 2.2 and the JSON binding API as well. And we started doing Spring Boot 2.0 milestones all along. So Spring Boot 2.0 is actually not final yet. It's going to have a last milestone next week, and then it's up for release candidate 1 very soon. All right, a few more words on what we're doing here and why we're doing it, right? So let's go back to the beginnings, right? Bean definitions and dependency injection, very essential pieces of the Spring story. Initially, this was programmatic, XML bean definition based, but the container itself was not XML based, right? It was basically a programmatic metadata model and an XML bean definition reader, literally, parsing those files into the programmatic model, which was always part of our API. So you could also create programmatic bean definitions yourself if you wanted to. This was back in the very early 1.x days. Now in 5.0, we're actually making good use of those programmatic facilities. If you do what we call functional style bean registration in 5.0, you're actually talking to some types in Spring that have been around for a long, long time. You're basically talking to the core container in a slightly different, slightly revised API style, but it's a little bit back to the roots to some degree, but back to the roots with new Java language features. So back to the days of decoupled external configuration formats. In particular, back to the days when the Spring Core container did not have annotation support. Over the years, the Spring Core container never let the annotation support sink in too deep. It was always a usage model on top, even for the core container, and in particular for the web layer, where the core container and the underlying infrastructure were always totally decoupled from annotation usage in general and the usage of specific annotations in particular. So this, of course, proved to be a huge benefit in being able to adopt and support different registration mechanisms later on, like right now in 5.0, right? So what we're doing here is that we are exploring options to register beans with the use of Java 8 language features, such as lambdas and method references. And for example, in this case, we're registering 2 beans. Let's assume a small targeted microservice, just a few service components. Without further specification, this would mean use the default constructor. This is actually a combination of the type that we intend to register and an instance supplier for creating an instance of that type. This is literally a Java util function supplier, type to bar in this case, and meant to create a new instance of that bean for us every time we're calling it. This is basically the equivalent of an annotated factory method, but expressed as a lambda expression. A slightly more sophisticated variant below. This is actually really subtle. So what are we doing here? We're still calling the default constructor, but we're actually specifying a reference to the default constructor of foo through a Java 8 method reference. Basically a part of the lambda expression story. A method reference to new without arguments means that we have a straight dispatching line to the constructor. There is no reflection involved. Whereas up here, if you're not giving any specific hints, we have to do essentially class new instance, which technically is reflection. In this model, in the functional registration model, we put ourselves into a rather extreme position, right? We said, like, what if we had mechanisms that allowed for the registration of a certain number of components in a convenient style, best possible use of Java 8 language features, no reflection, no annotations, no class bus scanning. At least no need to. So this basically doesn't use reflection. There's in the bytecode you'll find a direct invoke dynamic dispatch to the constructor of foo. And this is a slightly more sophisticated variant of this, still creating bar through a lambda expression saying new bar, referring back to another component that we pass into bar's constructor, calling back to the container and saying, like, dear container, please give me your primary instance for the foo type. I'm going to pass this in here. Programmatic, right? No auto-wide resolution, no reflective introspection of method parameters. And in the next line, we find yet another lambda expression. There can be any number of those. Following here, we are calling those bean definition customizers. It's a vararg, so you can have any number of those lines. You get a callback for the pre-populated bean definition that we are about to register. This is the programmatic metadata model underneath. This is the same old metadata model as in 2004. Well, it has a few refinements, but essentially it's the same model. You might want to fine-tune certain flags. You might want to add the lazy init flag here. You might want to add qualifiers, set some attributes for discovery in other places of your configuration arrangement. Anything you can programmatically do against the bean definition metadata is very conveniently accessible here. Of course, this is a rather extreme variant, right? In practice, you can, of course, mix and match. You can scan the class path for certain annotated components and add a few further components, register a few further components in this style. You can register all components in this style, but annotate your classes. Foo and bar may, of course, be annotated with further characteristics like add transactional and so forth being derived from annotations. Mixing and matching at every level, since this is the same standard co-container implementation in Spring that you are going to use in all other variants as well. However, you can choose to have the annotation features activated. Here they are actually not active, unless there is a specific instruction hiding somewhere. It's not active. If you want a convenient entry point for the mixing and matching, just do new annotation config application context here. The same API is available there, and all the annotation features kicking in if you need them, if you declare the corresponding annotations. And for the sweetness of it, I'm just going, this is not about Kotlin here today, but just giving you an indication for what we're doing with Kotlin. This is the same code essentially that you've seen before. It's creating the Spring generic application context and it's registering the same two beans. However, this is much more concise, significantly more concise, because we're making use of Kotlin runtime reflection features. So for example, here, we have to declare the bar type explicitly as a separate argument and an instance supplier for it. Because Java 8 Lambda expressions do not allow us to reliably infer the return type from a given Lambda expression. We just, at runtime, we cannot reliably find out that this will deliver a bar instance. So in Kotlin, there's a Kotlin function model, a K function model with a runtime reflection API. What we are doing here is that we are shipping Kotlin extension functions for generic application context. The Kotlin compiler picks them up automatically by convention, no special setup necessary, and there are overloaded register bean methods available that take K function arguments. And we are using the K function reflection API in Kotlin to determine the return type that the Kotlin compiler preserves at runtime here, so you don't have to say bar.class separately. And of course, K functions provide a couple of further nice characteristics. Any variant that the Kotlin language lets you do is then transparently available, right? So this is pretty Java stylish still. This is not an official term, by the way. I'm just calling this Gradle style because the Gradle Kotlin DSL suggests a similar style. It's essentially the same code with a different Kotlin notation, you know, like implicit access to the outer instance and a different type notation. This is available to us simply by exposing Kotlin extension functions and the Kotlin compiler doing its magic against it. We are shipping Kotlin extensions all across the code base. For the core container, for the lookup APIs in the core container, for the registration APIs, for JDBC templates, and of course for the web support, the WebFlex support in particular. All right. Even if it's not the main topic today, I'll spend a few minutes on the Reactive story. You might have seen the Reactive Web Services talk today, the live demo maybe. Anyone seen that one? Right. This was of course showing this in action. So I'll take it as the end of my little evolutionary tour here. This is of course also a very significant effort. What we are seeing here is the traditional Spring Web MVC stack and the Spring Web MVC module, the controller request mapping model on top, running on the Spring Web MVC facilities that have been growing over those 15 years. Spring Web MVC was a part of the framework since day one. The servlet API as a central abstraction, as a central API underneath, with the servlet API shining through here. So in a controller method up here and a handler method up here, you may even declare an HTTP servlet request argument or a HTTP session argument or a push build argument in servlet 4.0, and you get it resolved. So you intentionally, very explicitly build your web stack on top of the servlet API. Of course, runs on any servlet 3.1 container these days and higher underneath the covers. This still exists in Spring Framework 5 as is. It's a little bit re-architected in the details, some common web code to be shared with the other stack, but it essentially is the same Spring Web MVC as you know it. In particular, all the API and SPI contracts remain in place in a backwards compatible way. So if you have existing Spring Web MVC code or existing Spring Web MVC extensions, there are plenty out there in the open source ecosystem, you can keep using those. None of those breaks. In parallel to the minor evolution of that stack, there's a very major addition to Spring Framework 5, which is the reactive web stack. It's basically a separate but aligned web stack based on a reactive streams abstraction. Reactive streams is a very minimal interaction model between different components in a reactive stack. For example, between the data store driver and the web framework and the HTTP layer, the HTTP engine. Reactive streams provides a way to combine those pieces, different data store drivers, different web engines. We provide central reactive web abstractions that our Spring Web Flux framework, which is kind of WebMVC's companion here, builds on. So those are actually lower level. WebFlux is kind of the actual framework that you would be using directly. And you can choose to use the annotation-based model on top, which is very, very similar to Spring MVC in terms of style, in terms of structure. It reuses the same annotation types and some of the same API types, but no servlet API up here if you're building on WebFlux. So there are limitations, and there's in particular a different purpose for the handler methods. I'll get to that in a moment. And underneath the covers, there's a choice of HTTP engines that we chose to support, as HTTP engines. Don't get confused here too much by the presence of Tomcat and Jetty. These are Tomcat and Jetty, but not as servlet containers. We're rather taking the core HTTP engine from each of them, the core data buffer abstraction, the native data buffer abstraction for both of them, and we adapt our reactive streams layer on top of those HTTP engines. So it's Tomcat and Jetty here, but not as servlet containers. The servlet API does not leak through here. Netty, of course, isn't servlet-based. It's the reference model for reactive web stacks. It's the most powerful, most comprehensive, most customizable networking stack out there in the JVM ecosystem, which of course was a very important option for us to support. And with Undertow, we mean the web server that's also used in Wildfly, but not the servlet container. We mean Undertow core. Undertow, through the benefit of late birth, was always decomposed into a core HTTP engine and a separate servlet project building on top of it. We are adapting this to core, of course. All right, so what does this look like? It's an annotation-based component, much like the one we've seen before. This is very intentional, of course, same mapping annotation, same structure, but the purpose of the handler methods is slightly different. The handler methods are being dispatched to whenever a corresponding matching request comes in, when the predicate matches. But we actually, a further similarity, we have the flexible signatures. We can do path variable resolution, request header, cookie value resolution through flexible signatures, automatic type conversion, and parameter level annotations triggering this. But the purpose of the actual method is not to process the request, like in the servlet model, where we actually own the thread, process the request, write out a response, and then we are done and return the thread to the pool. In the good old servlet model, this is different. We are being called within an event loop. And within an event loop, the purpose of the method is to return a reactive streams publisher. Basically to build a publisher, a chain of operations that can deliver an HTTP response eventually to return that to the runtime system. So if a get user for a particular ID comes in, corresponding request, in this case we assume there's a repository that can do most of the job for us. If the repository is already using the same reactive abstraction, even better, just pass it through, right? In the end, the signature is very flexible. It can be any reactive streams publisher. What you're seeing here is like in the demo earlier today. This is Mono and Flux coming from the Project Reactor codebase, Project Reactor API. Mono is essentially a rich API type for building a reactive streams publisher capable of delivering one element or none. And Flux is essentially a reactive stream, a rich API for building a sequence of elements coming out of the publisher. So those methods essentially just build a couple of objects, a couple of instructions, and return. So they don't do any I/O, they do not block at that point. They almost immediately return and leave it up to the runtime reactive web stack to figure out when to trigger those individual steps. So whenever a subscriber comes in, whenever we are ready to write to the HTTP response, whenever the networking stack suggests that we can write to its buffer now, then and only then the runtime system is going to start triggering some operations in this publisher. So in Reactive Streams terms, the response subscriber then takes a few elements from the publisher that we're giving it here. So it's a quite different arrangement. We don't own the thread here. We're not supposed to actually process anything. We're not supposed to do any I/O or to block. We're just building a chain of instructions and returning them. So this is essentially the purpose of a reactive web controller. All right, and since I quickly had it on the slide before, a functional registration is also available here, just giving you a rough idea of what this can feel like. This is expressing the same endpoint arrangement in a functional registration model. No annotations, no reflection. So building a router function and saying for a request matching this incoming predicate, this is the code to arrive at the server response. It's more programmatic, of course. It's less convention-based than the annotation-based model. No flexible signatures here. You get a server request API handle passed in. You can ask that request to extract a path variable. You have to convert it. You are passing it to the repository using Java 8 language style. You arrive at a mono of user, a publisher that is able to produce the body of your HTTP response. The API forces you to return a server response. So you're saying server response, this is the suggested HTTP status, and here is how to build the body. Please send it through the codec arrangement at runtime. So if there's a Jackson codec registered, it can react to your user object and render out a JSON representation of it. There are actually two routes here. So it's two routes combined for the same two endpoints that we had before. This one is more straightforward since we don't have to handle any incoming variables. So again, the functional perspective coming back into the picture. Same underlying abstractions, same underlying reactive web stack, Project Reactor, the choice of 4 first-class supported HTTP engines underneath the covers, with an annotation-based model as shown here, or with the functional model as shown here. So this is these are the essentials of what we're doing in Spring Framework 5, which is to quite some degree a little bit radical, but it appears more radical as it actually is. You can take an existing Spring Framework 4 for the 3-based application in particular, just update the version numbers in your POM to 5.01, 5.42, and in all likelihood it's just going to work if you're using the same facilities as before. So no need to use the reactive stack. You can keep using Spring MVC on the servlet stack, no problem at all, right? However, if you choose to dive into the reactive stack, there's a couple of sister releases of Spring Framework 5, like the Spring Data K release, providing out-of-the-box repository, an out-of-the-box repository model for currently available reactive data store drivers, for example, for Couchbase, for Mongo, for all the databases that actually have reactively enabled drivers. Spring Data K provides out-of-the-box support as a part of its reactive repository model. So the code that we've seen before, where there is a repository that basically does the job and returns a publisher for us already, is actually available out of the box here in typical Spring Data style. And all of these things are going to be wrapped up in Spring Boot 2.0. M7 coming next week, RC1 very soon after, basically bounded by the Spring 1 conference, which happens in the first week of December. RC1 is going to be out a few days ahead of it. Spring Boot 2.0 brings many of those efforts together, not just Spring Framework 5 and Spring Data K, but also, for example, Spring Integration 5, Spring Security 5, Spring Batch 4.0, and a few others. Spring Boot 2.0 actually has 2 different web stacks as well. So you can choose to use the traditional servlet-based web stack or the reactive stack. It will try to pre-configure your dependencies for each of those stacks. You may also choose to mix and match a little. There's actually some reactive support in Spring MVC if you have a reactive data store driver available for some of the endpoints there. So there's a lot of gray in between. I've basically just shown you the pillars of the plan. There's a lot of gray that we allow for in between, lots of mixing and matching. But Spring Boot 2.0 and start.spring.io in particular come with dedicated starters now. So if you'd like to give these things a try, go to start.spring.io, select Spring Boot 2.0 milestone, and you get the latest milestone, and you can already choose to get started with either Spring MVC on Spring Boot 2.0 or Spring Webflux on Spring Boot 2.0. And you can even choose to get started with Kotlin. So there's quite a bit of out-of-the-box guidance for starting a Kotlin-based Spring Boot 2 project. in the meantime. All right, well, so much for this tour. Trying to check the time, so yeah, we're like 5 minutes over. This is, of course, not the end of the story, right? It's just the end of this 15-year tour. For us, Spring Framework 5.0 is the beginning of a new generation. We have lots of little ideas, follow-up ideas that we intend to address in the 5.1 and the 5.2 release. So we're doing, in its further evolution, this is our new baseline, our new fundamental generation that we're building upon. 5.1 is already planned for May in 5.1 GA, and 5.2 GA is planned for end of next year, December next year, picking up some other releases next year. Like I mentioned at the beginning, we are not on an island. We actually co-evolve a lot. Project Reactive is actually a pivotal project, so Project Reactive's committers are all colleagues of mine. But quite a few of those efforts are, of course, collaborations with other stakeholders. Kotlin is done by JetBrains. We have a very, very productive relationship with JetBrains. We are already involved in where Kotlin 1.2 and 1.3 is going. This is really a co-evolution between what we are doing with Kotlin on the server side and the roadmap that JetBrains has for the Kotlin language. So we're really trying to influence it as well to some degree. And JetBrains appreciates a lot that we're providing so much design feedback to them for this particular part of the market, right? Kotlin establishes itself for the Android space, which is not really our world. We kind of cover a lot of the Kotlin experience that is already has been accumulated in the enterprise Java space. So it's a collaboration with JetBrains. We are going to pick up the 2 new Kotlin releases next year, very ambitiously, the upcoming Reactor releases. There's a Reactor 3.2 planned early next year. And of course, new JDK generations, because you might have heard there's a new JDK release cadence. We had to wait 3.5 years for JDK 9, but now we'll get a new JDK release every half year, every 6 months, right? Is that a hooray, or is that? I'm a little torn myself. I find it slightly too radical, frankly speaking. I would have preferred a new JDK release every year, every 12 months. But it is what it is. They intend to release JDK 10 in March and JDK 11 next September. Unfortunately, that means that JDK 9 is just a short-lived release. It's not a long-term support release, so if you're now on JDK 9, you're supposed to upgrade to JDK 10 in March and to JDK 11 next September. And only JDK 11 is the next long-term support release, a little bit like in the Ubuntu model, right? So for framework implementers, framework providers like us, this is a little bit of a challenge. We have to track those JDKs every half year. We have to make sure that the same framework generation of ours runs fine on not only JDK 8, but 9 and 10 and 11 and everything that follows, right? So we have to cover quite some ground in terms of different JDK generations. Since we technically went very far with our JDK 9 preparations already, I'm happy to declare that at this very day, we even run fine on JDK 10 early access. The entire Spring Framework build runs fine, all the tests pass. So I don't see any showstoppers along the way, but we'll have to, all of us, right, the entire community here has to adapt to the new release model here. It is, for better or for worse, right, a high frequency of releases from now on in the JDK. Our JDK 8 baseline is going to be with us for a long time, because we totally understand that JDK 8 is the new JDK 6, the one JDK generation that everybody's using, and it will be around with us for a long time, for many years to come. It's totally clear at this point, in particular since the next long-term support release is only JDK 11, only next September, only then people can start upgrading. JDK 8 is going to be with us for the foreseeable future as a baseline, but that's okay. We can do many things, lots of goodness with JDK 8, and at the same time we're going to embrace every new JDK generation as it is being released. We are putting ourselves, yourself, into a position where, as an existing Spring Framework-based application, you can always, if you're on a very recent Spring Framework release at least, you can always upgrade to a new upcoming JDK generation. So if you pick Spring Framework 5.03 or 5.04 now, you can probably in all likelihood stay on that release, and in March just upgrade to JDK 10, and it's all going to work fine because we are anticipating what happens in March, and we are providing forward compatibility. We are doing our job early, so that you don't always have to upgrade your framework when trying a new JDK. So yeah, this is essentially the plan going forward. I usually plan for the next 12 to 18 months. I mean, in retrospect, it all looks like a one long story, but in reality, of course, you never know what's happening in 2 years' time. You never know what's successful and what's not. You never know whether the promised JDK release actually happens or not, like with JDK 8 or 9. We had to wait a lot. We don't know whether Kotlin will be successful. It looks like it, right? There's a lot of interest. In all likelihood, it will be quite successful, but how that translates to market share, we'll see, right? And the same goes for the reactive stack. If newly started Spring applications right now, Spring Boot 2.0 applications right now, if 90%, even 95% of them stay on the servlet stack, that's totally okay, right? It's a matter of requirements, a matter of architecture that you're trying to build. Maybe I'm proven wrong, and half of new Spring-based projects are going to be built on Webflux. I simply do not know. It's a little bit like with JDK 8 and with WebSockets back then, right? We'll see. We'll find out. It's essentially your call, right? A call out to all the application architects out there. Try to understand your requirements and build a corresponding architecture for it. We essentially provide all the tools that are necessary to build a 2018 era stack these days, web stack in particular, and let us know how it goes. All right, so thanks for listening so far. And if there are any questions, this is a small enough room that you can just drop them my way. And there's I think there's the keynote coming up, but we still have a few minutes, and I'm here for a little bit longer. So, any questions?